Here for the today's webinar organized by Department of Electronics and Communication Engineering. I'm Subhash R, student of St. Joseph's Institute of Technology. I'm here to volunteer today's session. Now, I request Dr. Gnana Kausalya ma'am, professor and head of staff and student affairs to take over and address the session.
Thank you, Subhash. Good day, Dr. Krishna Kumar and participants. Good evening. Here it is Jnana Kausalya, Professor and Head Department of ECE, St. Joseph Institute of Technology, St. Joseph Group of Institution, Chennai, India. On behalf of St. Joseph's family, I am very happy to welcome our today's speaker, R. Josephate, Dr. Krishna Kumar Nahalingam, Product Advisor, Energy Product and Engineering, Kongsberg Maritime AS, Kongsberg, Norway, to give a talk on artificial intelligence and the era of autonomous shipping. Welcome, Dr. Krishna Kumar. Warm welcome to all the
Thank you.
participants from various places. I hope this session is going to be an interactive session. About Dr. Krishna Kumar, he completed his UG in Yandai from Anna University in St. Joseph College of Engineering in the year 2006, and he is a gold medalist. MS in Computer Control and Automation from Nanyang Technological University, Singapore in the year 2007 with CPA of 4.81 out of 5, and PhD in Electrical and Computer Engineering at NUS Singapore. And regarding his profession experience, he worked as project engineer, site lead, technical manager from July 2007 to February 2019. From March 2019, is holding the position from as a product advisor energy solution in Kongsberg Maritime AS. His contribution in developing the roadmap of energy product integration, critical design reviews for the hybrid and DC solution, innovation at energy solution level, and also to develop an architecture and design for energy efficient features for the next generation autonomous ship. So these were some of the innovation or the positions or the contribution of Dr. Krishna Kumar. And he also published many papers in the reputed journals. And he also involved himself in many of the projects in the Seadrill, Norway, Larsen Oil and Gas, Norway, Blue Water Energy Services, Netherlands, and in many of the companies he did many of his projects are related with the autonomous shipping. And now coming to we are very proud and we are very happy to reserve Dr. Krishna Kumar for a special reason that he is our Josephite. He's from our Josephite family. So very warm welcome to Dr. Krishna Kumar. Happy to
Thank you.
receive you, and we are very much eager to hear your speech. Thank you, Pa. Thank you, Dr. Krishna Kumar. Thank you.
Thank you very much for the kind invitation and a brief summary about myself. And I would like to express my sincere thanks to the Department of ECE at St. Joseph Institute of Technology, the head of the department, the professors and the coordinators, and the chairman, the director of the institute, and it's been a proud moment for me to give a webinar for many of the students and maybe from people from several industries. I hope this webinar will be some informative session for all the participants. And I'm not a professional speaker, by the way, so this is an amateur. This might be an amateur presentation from me. So please bear with me if I've been bit dragging at some places, or if you find the session is not that much of interactive to you. I will try to make sure that you get a best experience from this talk. With that, I would like to proceed with my presentation. Today, I'm not going to dive into the technology part of autonomous shipping or the role of artificial intelligence in autonomous shipping. I will just scratch the surface of the subject. So it gives an insight for the participants on what is autonomous shipping is all about, and what Kongsberg is playing a role in autonomous shipping. And to begin with, I will like to present, I would like to start with a brief introduction onto about Kongsberg. Kongsberg has a company headquartered in Norway. It has more than 200 years of technological innovation services to several industries, from deep sea, some and all the way to the outer space. So in Kongsberg is a big group. It has products ranging from underwater systems to defense, to fisheries, to um, aerospace, and all the way to fighter jets and missiles and cargo vessels and so on. So it has footprints from deep sea all the way to the outer space. And Kongsberg Maritime is a part of the Kongsberg Group. And in Maritime, we have plenty of opportunities. So we start with fisheries, we start with autonomy, we start with underwater vehicles, with oil and gas production and digitalization. And we are a pioneer in delivering a sophisticated vessel control system and a dynamic positioning system, which is a vessel positioning system, which is very much useful for offshore oil exploration and research and several other projects. So how the thought of autonomy came to maritime, it's all started from car industry, as we all aware. Car industries are always fascinating. Every time they come up with a lot of latest technologies, and there are several good companies who are innovators of a lot of technologies, and that has driven several other industries as well. And maritime is one such industry, because the first era of digitalization on a commercial level happened in a car industry. So if you go and look at the typical car in 80s and 90s, the dashboards, it's more analog compared to the cars which we have now. It's completely digitalized. You have a lot of touch functions. You have a lot of data analysis behind it. And you use this data, and then you are presenting a lot of valuable information to the driver. And it also helps the car manufacturer to kind of improvise their product by understanding their customer, and also improvise the safety and the technicality and the comfort levels of the product. So to begin autonomous car, they are expecting close to 10 million autonomous vehicles all over the world will hit the road in 2030. But we are in a challenging situation now with COVID-19, and no one knows when this pandemic is going to end, or if it's going to be something that we have to live with the virus. Maybe I think many countries are going towards that direction, but the technology is still going at the background. And what is the reason for car industry to move into an autonomy? They, based on several studies, it's been understood that an autonomous vehicle could lead to 90% reduction in vehicle crashes, and it could also generate more than 7 trillion of annual economy by 2050. And it also puts you up forth of electrification of cars, which means you will go less and less on fossil fuels like petrol and diesels, and you are moving more towards fuel cells and batteries. And that is also very helpful in terms of global concern, in terms of greenhouse emission reduction and so on. But on with even though the autonomy has a lot of opportunities like reduction in vehicle crashes, reduction in traffic congestions, to avoid a bottleneck on a big cities, especially during the peak times. It could always help you to maintain this speed and go within the lane, and it could avoid unnecessary speeding and braking. So with all that nice features around autonomy, also have some technical challenges which needs to be met, like cyber security attack. The picture you can see here is a news from CNN, where the hackers has remotely hijacked an autonomous jeep on a trial, and then it was just shut down. Sorry, yeah, and it was like stopped somewhere on the highway. So that is a key issue when it comes to autonomy, that cyber security. and the liability of autonomous vehicles. Like if an autonomous vehicle meets with an accident, who is liable for it? Is it the person who owns the car, or is it the company which manufactured the car? So there are a lot of regulations and complication when it comes to liability, and also the laws, what kind of laws that needs to be scratched for this autonomous vehicles, that is still a question, and many governments are actually working towards it, and these are mostly driven by the industries in motivating the government to move towards autonomous vehicles. Also, we all know the front ender in autonomy vehicle now is Tesla, and there are several other top automobile companies like Toyota, BMW, Audi. They are all competing very much with Tesla to come up with an autonomy vehicle. Uh, and next thing is data privacy. As we know that we are living in an era of digitalization, where is it easy to collect data from several users and do a global analysis on it, like big data analysis, and then kind of improvise a product. That's the kind of strategy which several digital companies are using, like Google, Facebook, Amazon, and YouTube's and so on. And when it comes to autonomy, we also have the same challenge, because if you have 10 different cars of autonomy driving in different areas, all the data are collected. And when it comes to data collected from individual person, then it comes to the data privacy issue. So several countries are very strict when it comes to data privacy. So how is it being handled? That's another challenge for car industry when it comes to autonomy. And the key technologies which are very much involved in car industry is the sensor and the control and navigation equipment that is built in the car, like the cameras, the range detections sensors to detect how far is the car in front of you, and do you have any obstacles on the sides, and also the connection to the global positioning system to track you and to guide you within the path, and the artificial intelligence of it, like the system has to learn certain, for example, if a person is driving from his office to home and that's the route which he's been taking very well, then the system can learn over the period that I know how this road is going to be. I know where the turns and where the terrains are going to change, and I don't know where the traffic lights are going to come. So it's the system has to learn over the period of time. And then, as I said, this lidar, which is a laser based technique which is used to detect the ranges, and it's mostly built by US Navy and NASA, and now it's been used in several commercial applications. Yeah, with that all said about car industry, then we move towards maritime, and the maritime systems are also, as I said, is more fascinated by the development in car industry. And we also want to, and not we in the sense, Kongsberg and our several other competitors, they also started thinking of autonomy system for maritimes. And when it comes to that, we already have some autonomy systems like the remote operated vehicles, which is used for subsea explorations, like and also this autonomous underwater vehicles, AUVs, which is used for seabed mapping, especially to study the geology of the seabeds, mainly used for several reasons like mining, subsea oil exploration, and also for research on also to understand the marine life and so on. So that is an unmanned underwater vehicle. So it's completely remote, and it's operated mainly from a remote control, or it goes on an autonomous way. When it comes to surface vehicles, the challenge is when we come to surface vehicles, because when it comes to surface vehicles, it's again like a car, but the platform is different. You're driving on a water. And when it comes to that, you have two kinds of ships. One is a small speedboat, like a surface vehicle, which is used for maneuvering for any short-term, like a coast guard or it's like a speedboat approach. And then comes this maritime surface ships, which is mainly like a bulk carriers, like a car carriers, containers, like all those cargo or commercial vessels. Yeah. So what is the benefit on moving for autonomous shipping? Why we want to go autonomous shipping because we already have a very well established shipping industry with a lot of very good crew, operation crews and so on, and they could run the vessel very effectively. It's the same thinking as autonomy car. You have person who knows how to drive the vehicle, how to handle it and so on. Then why are you moving to autonomy? It's the same question when it comes to autonomous shipping, but still there are some benefits. Like it could reduce the human error because there are a lot of accidents that happens at the sea, which leads to both environmental damage and material damage, and it also puts the crew's life at risk. So you have accidents that leads to death and damage to the environment and damage to the property and several other issues. So autonomy is when it comes to missions are very precise in what they have to do, and the approach of robots and missions has been there since in the last 2 decades from manufacturing industries and so on. So to me, I feel autonomy is just a next evolution of what we already have in the manufacturing sectors when it comes to use of robots and so on. So autonomy is just an extension of it, as I see, and then you have several critical importance when it comes to autonomous shipping, why we need it. It could increase the human safety. It could help you to remote monitor the cargo conditions on what is being carried. And I think I have repeated twice, sorry for that. And then it could help you in reduction of operational cost, because every shipping industries are struggling with the operation cost due to the increase in the materials and due to increase in capex, the capital cost, and then the opex always also increases, which is the operating cost for an equipment. So an autonomy shipping can help in to have a reduced number of crews, and they could have a very uh, optimized way of routing the vessel, and they could take a control at any time of time. So it has a lot of benefits, so which could help in reducing the operating cost. It could also help you to monitor the machinery performance, like how the engines are running, how the thrusters are running, how the thrusters are running, how the engines are running, and the cranes and several other components. We can monitor it. And again, the crew space is reduced, and by reducing the crew space, which means you don't need a big living quarters, because if you take an offshore vessels, you have that the living quarters where the crew are going to sleep, that occupies quite a lot of space on the deck, which is an additional weight to the vessel that could be taken out, which means you have less weight on the ship, and that is actually helping you to have less fuel consumption, because you don't need to drive, the whole weight of the ship is reduced, and that is helping in less fuel consumption as well. And those space, if they want, they could use it for cargo. And when it comes to the level of autonomy, same as car, in ships, and we have several levels of autonomy scaling from 1 to 10. 1 is that the computer does not do any help. It's all the humans that has to take action and decisions. This is how it is now. But it's slightly not the same as what we have now, because there are several new concepts like digitalization, where they have a supportive decision support tool from the computers. But what we are achieving, what we are want to achieve is to a scale of 10, where the computer decides everything and everything goes in autonomy, like without any human intervention. And when it comes to ship, based on the level of autonomy, as I said, we have 10 scales, and then we further classify it into several levels, like manned bridge, unmanned bridge with a crew on board, but unmanned bridge with no crew on board. So this is full autonomous. Manned bridge is that you still have the crew on board, but the crew will have a decision support tool, which means there is no autonomy, but you have a decision support tool to tell you what action should be taken, looking at different parameters around the ship. And then when it comes to unmanned, you still have some crew on board, but you don't have a bridge like a controls room, and that is done from remote. this is a way to put the ship into an autonomy track. So to begin with, we go for decision support, and then to take out the crew, which means we take out the control from the ship to a remote center. And the next step is to even to remove the remote ship and leave the ship to go for full autonomy. Yeah. So there are some test projects that has already been done with that thinking. And as you can see, there are some autonomy concepts like which is used for auto docking and for auto crossing and adaptive transit in the sense like if a ship is going from port A to port B, it's called transit in marine industry. And you can also use for trailer transports like carrying heavy cargos that can go like a barge kind of thinking that can go from one port to another port without any human intervention. And for seabed exploration, so you can have a remote autonomy ship, which is this is a research project which was done together with Cell, and Kongsberg was a partner of it, and several other research groups. And this goes onto sea, and it can go autonomy, and then it has an underwater vehicle that is dropped, and then that just does a seabed survey, and then it's been retracted back. And a remote firefighting system, which is very handy when it comes to if there is a fire on a ship or outside, then this can be this can be set out to put out the fire and so on. So that is also very handy, and it's controlled from remote. I just touch upon some of this project which has been done by Kongsberg. So Bosto Fosen is a ferry in Norway, and it has an automatic bridge with an operator as assistance, which means it is used for auto docking. Later I will show you a video on what is auto docking is and how an remote assistance can help. This Robert Allan is a test project. This is not the actual picture, but this is a prototype, and this is a remote control firefighting thinking, and it's unmanned. There is no control room. You can see the deck. There is no area for control room. There is no crew on board. It's completely unmanned bridge with no crew. So it falls under this category. And then this is a fully autonomous, which I said before, the seabed exploration, which has an underwater autonomous vehicle, and that is full autonomous, which has no crew, and it's not remote operated. It's just you just need to tell what it has to do, then it just go and finish the operation and come back. And when it comes to autonomy, as I said, the remote control is a key part, and we call it as this shore control center, which means when you put the vessel out there, you still have a risk on anything can go wrong. And if something goes wrong, you need to take action from a shore control center so that you don't end up in any accidents which could cause material damage or environmental damage or even potential damage to any people out in the sea. And how are we doing is we are actually comparing how the vessel is operating with the sea using a digital twin of the vessel. So we compare what is the actual operation of the vessel to a digital twin of the same, and then we see whether whether the AI is actually doing the right thing or if there are any deviation in what it has supposed to be do. And the remote control center will also say how to manage several autonomous vessels out in the sea and also to have a planning. It's more like the air traffic control center, which we normally have. And then it also help you for monitoring and control. And autonomous voyage phases, we have several phases as we saw before. So it's unmanned ship is completely unmanned, but periodically, and then you have completely unmanned bridge periodically unmanned bridge, and then you have continuously unmanned ship, which means I don't want to go into details of this, but just to give an idea. So there are three layers of what we want to try, which is you have a crew, but it's not on a regular basis. You have a control. The bridge is actually the control center on the it's called navigation bridge, where your captain and the sailors are watching the sea and driving the ship. So it goes with unmanned bridge and then continuous unmanned bridge, which is completely autonomous. So it goes when it how the path is when it leaves the breath. If we take for autonomy, it uses an automatic bridge concept, and then it leaves the port, which is a remote control, and then it goes into the sea, open sea, and then it's continuously autonomous. And then when it goes to another port, when it's nearing another port, then the remote control center takes action. And then when it goes again to open sea, then it goes to continuous autonomous. Later I will show you a video from where we could see how the automatic bridge thinking is being used in the autonomy. Okay, so when it comes to components of autonomy, this is Yara Land is the world's first autonomous ship, which is being built now. It is built in Norway together with Yara, which is a fertilizer manufacturer, and with Kongsberg. The idea is for the ship is to manufacture fertilizer from one manufacturing port in Norway to another area in Norway. And for now, they are using several hundreds, thousands of truck doing this shuttling back and forth. And that is a lot of fuel consumption, and you have a lot of CO2 and NOx emissions. So in order to avoid that, we go for the concept of autonomy. Electrified ship has put into place, and this ship is purely battery driven, which means it's zero emission ship. And the concept of the ship, as you can see, it has a power and vessel automation system, which is providing the power supply to several machinery on board, and also to control the auxiliaries like the typical DCS system. And then you have a system which is called situational awareness, that is to understand the environment around you, like CCTV cameras, a PTZ, which is pan, tilt, and zoom type cameras that has 360 degrees, and then you're connected to a GPS system. So the vessel knows what is it looking ahead, and it also has cameras that the crew can actually, like crew in the sense the remote control center can take a control of this camera by panning, zooming, and so on. And then you also have a navigation block where you have an autonomous engines, and then you have an advanced maneuvering facilities, which means the system knows which heading it need to turn, and what is the speed it should maintain, and so on. And then the key in autonomy is the communication. You need a very robust communication in order to transfer all the data from several equipments on the ship back to the shore control center, and also also for the shore control center to take over the control of the ship in case of an emergency situation. And then we also have a broadband, maritime certified broadband radio that is helping in transferring quite a lot of data. So you have a higher bandwidth that helps you to have a better communication to the vessel, and also to collect the data from the vessel, which is very key for the shore control center. Yes, and moving forward, I would like to touch upon some of the ongoing activities within Kongsberg, and mainly in Kongsberg. You can see we started with steam engines, and then we ended up into mass production of ships, and then it started into container ships with several engines. And now after 2010, we are more into digitalization era, which means we are getting a lot of data from the ship, which helps us to understand the complex operations on the ship. And then it also gives an idea for the several companies to plan on how to optimize the ship, and so on. And as we can see, there are several companies which are using big data analysis, and we are in fourth generation of ship intelligence now. And What is the help of digitalization is because it helps us to connect to several business platforms and several ships, and it also helps us to move forward to autonomy, and then it brings more efficient way of operating a ship. And for the environment, it helps us to reduce the global footprint, and also low NOx and sulfur emission, which is highly been spoken in several countries now, and there is a lot of focus on this. And that's the reason many companies are moving towards autonomy and also moving towards electrification, like using batteries and fuel cells and LNGs instead of fossil fuels. So how is it done? We are now in this place where we moved from decision support to an to starting with an automatic thinking, and moving ahead we go into this constrained autonomous, which we saw earlier, with an unmanned, periodically unmanned bridge or ship, which means you still have the crew on board, but they don't take any action unless if there is anything emergency, to let the system to do its function. And then we move further into uh, unmanned bridge, like, but you take control from a remote center, and then moving into autonomous. We don't know when, but it's a future where we are going towards, together with several other top-notch companies in the world. So what are the three pillars of an autonomy operation? Is that you need a very good infrastructure on board to situational awareness system, like the vessel should actually know where is it, what is it doing, and so on. And then it has to transfer the information via a secured communication, which is very important. As you know, these cyber attacks could be a danger for autonomy, because when you put all these autonomy ships out in the ocean, and then it carries a lot of valuable goods, and it's very easy for its pirates to just log in, hack in, and then they could bring the ship to their backyard. So cyber security is a key point here. And then a remote control center, if something goes wrong, then a remote control center can step in to take action. And we have different layers on all these three pillars. The vessel, we need it to operate, to maneuver in the sense to move around, to navigate the vessel, and to have a plan. What should be the plan in managing the mission? And I also need to look around myself, where I am, what I'm doing, and so on, and also to understand the equipments, because you don't have a crew on board, so you don't know if there is a failure in a cooling pump, if there is a failure in a ventilation system. That needs to be known upfront, so that vessel could be used, brought back to a shore to go for a service. This is a video from one of auto docking. As I said before, you can see a ferry. I hope the video is playing for you. Just let me know if if you can see the video. You can see a ferry is been approaching a dock, and then it's been auto docked, and you can see uh, the screen where the operator is seeing that it's initiating a dock, and then it's taking over automatically. It's adjusting the speeds, it's adjusting the position, and then it adjusts the thrusters directions in order to slow down and to properly dock the ship. Yeah. Yes. So what is the view normally we have on a remote control center? This is a typical view we will have in a remote control center. It's more like an autonomy. Say this is your vessel and this is your trajectory. So that, which means you have to go in this direction. But you have another container vessel here. You have another cargo vessel here, and then you have a small fishing boat. But what is happening, the situational awareness system on board the vessel, the cameras and the lidar is actually, and also we use the navigation system which knows what vessel is around me, and we also use the radar images. And then we know that this vessel is in 300 meters, this is in 250 meters, and this is in 200 meters, and this is the heading you're going on. And here you can see what is your thrusters doing, and which direction the vessel is going to take, and how is the power system is doing, and some other information on about the voyage, which means the vessel is going from Oslo to another location, and when they started, how long is the travel, and what are they doing. All those informations can be seen here. And then it sees a view that the vessel is here, you are looking ahead, this is the view on the radar, and then you're going into a shallow water, and then you're seeing a small vessel in front of you. And this is a night mode view. So in night mode, you still have a very good view on your track and what you have around you. So the situational awareness is very important. I will play one another video on this situational awareness. Here you can see how the situational awareness sensors are fused to give you a complete view of the trajectory and also the things around the vessel. Like you can see the vessel is moving in this trajectory, and it also shows the waypoint. Waypoint is that the point where the vessel is going to change the heading. Heading in the sense is just like you're driving a car, and then where you're going to change your direction, and what is the distance from your position to the next point where you have to change the direction. So it's like in 0.4 nautical miles, and this shows your heading in 335, and this shows your speed over the ground like 16 knots. And then you also see a ferry is crossing at a 0.8 nautical miles, and also you can see the name of the ferry. Yeah, I just play the video. Even a small fishing boat is also detected. All these are done by image recognition in machine learning, and you can also, and in combination with the ECDIS, which is an electronic chart and map that's normally used for navigation. So you merge, you actually what are you doing is you're merging the radar, the camera picture, and then you're also mapping, merging the map. So that's why it's called fusion. You're actually fusing everything into one to get a real-time view for the ship, so that it knows how it should continue with this travel. Oops, I will move the video further a bit. Sorry about that. I pressed the wrong keys. Yeah, just continue with this video now. You can also see what is the distance from you to that vessel, and it also says what is that vessel type and what is your distance. And yeah, it goes like this is a lesser craft. This is like a sector light, and even small objects. You can see a small craft like a fishing boat there, which is very small, but still the system is able to detect. Yes, this is what I meant before. We are actually mapping the radar and the optical sensors which we have on board, like the cameras. And here you can see the raw version of the video, like you're moving, and then you can see how the objects are being detected. You can see, you set a trajectory, and then you want the ship to know that you should go within this trajectory, and then you can see how the image identification knows in front what are the obstacles you have. Yeah, now we are approaching the port. Here things becomes complicated, because when you're in open sea, you still have enough space and time to react, because it's not so much traffic out there. But when you're close to the port, then things becomes a bit complex because you have a lot of objects and it's crowded. It's same as like how we drive a car in a heavily traffic roads, but still you can see the system is able to identify all the objects in front, and then it's even says if it's a ship or if it's a small boat or if it's a building, and then it goes into an auto docking mode. As you can see, it's like it knows there is a dock. You can see in this view very clearly it starts to use different reference points, and then it knows how much meter where I should dock. This is a fixed reference, and it also has a reference on the ship. So it takes those reference and then it slides in and does an auto dock. This is same like a robot. It's the same thinking. So where you have a robot moving through a trajectory by looking at fixed references using image classification, image processing thinking. Yes. I would like to play another short clipping. I hope these videos are interesting for the viewers as well. It's because more talking, it's better to see some nice videos on what is being done so far. So it's the same thing. Now the vessel is leaving the port and it's going into the open sea. And all these points means the cameras and the reference systems we have on board. Yes. Then we move slightly into what artificial intelligence is playing a role on this context of autonomy. Yes. What are the different types of artificial intelligence or machine learning? Is that we have four different types. It's reactive type, which means the system has no internal memory, like it does not have a memory like a brain. It just responds to some external stimuli. And a limited memory, which means it has some kind of memory to learn or to store what it learned, and it could improvise itself. And a theory of mind, which is more like a thinking of brain, which means it could understand the needs of other entities, which means it knows what it has to do and then it tries to interact with other things around it. And being self-aware, which is completely autonomy, like it becomes like a human, which means it has the necessary intelligence and it knows what it needs to do and it's aware of it. uh, there is some issue with this animation, I think. So yeah, when it comes to artificial intelligence and machine learning, you can see artificial intelligence is a big balloon here, and then machine learning is a sub part of artificial intelligence. In machine learning, we are having several types of options like supervised learning, unsupervised learning, reinforcement learning, and the very recent, not recent, it's been there for a decade, is this deep learning, which helps you to understand more on how the brain will operate, and it also helps you to understand non-linear and stochastic data, like any process which is stochastic in nature, which could be realized by a machine learning system using deep learning. And autonomy is more like a stochastic system where things can go wrong anytime and it's very unpredictable. Yeah. I will move on to the key technologies. What is needed in an autonomy is you need a sensors. You need sensors to understand perception of it. And then once you perception, you need to have a cognitive thinking, like what should be planned and how I can learn and adapt to it. And you need a very good mapping system, and you need a communication system. You need the power and energy. You need things to coordinate the different systems on board, and then you need a human interaction, which is the store control, and then all the things has some systems that needs to be developed. Yes, we start with the autonomous vehicle pipeline, like taking a car as an example. So you have, as we see, we have a situational awareness, which is the cameras and the short range radars or lidars. Tesla and Google has references there, and that is put into a processing, data processing, which is very important to merge the GPS and other inertial sensors, and also the situational awareness sensors to form a sensor fusion, which we saw a few videos there, how the camera image is mapped with the real-time camera image is mapped with the information from a positioning or AI system, which we call it as automatic identification system, and then everything is fused to get an overview on the situation. And then you also need to know what is the map where we are going to drive, and then you need to know what is the vehicle position, and it also needs to estimate whenever it starts to maneuver. And main importantly, you need to have a navigating automatic navigation system, and it also needs to avoid any collision. The same thinking is moved into maritime. Again, we are using the same thinking like cameras. This was a pretty old image, but now we are also included lidars and radars, which here is written also to be investigated, but it's already done. So we also use the long range radar, that is the S-band radar and the X-band radars on board, and then you use the cameras, do the same sensor fusion. But what is important in marine autonomous is how is it different from car, is that in car the challenge is you will have different terrains, which means you can drive on a flat surface, you can drive on a hilly surface, it could be a rainy condition, or it could be a snow condition, and you also have pretty much you always have a traffic around you. But when it comes to autonomy vessels, the key is the weather, which is affecting the vessel motion. So if you know the weather upfront, then you can have a better route optimization. Like if you know there is a storm, or if you have a low pressure in some areas, you can actually arrange your trajectory in another way. Or if you use an autonomy vessel, it could always have a best route optimization, which has less fuel consumption or energy consumption. Yeah, so that's the on marine. You always have the same surface, is the same sea, but you have different water depths. That's the only difference, but the weather is a key in maritime. And then you do the sensor fusion, and then it's the same thinking. Here you use, instead of using a 3D map like a Google 3D map or something, here we are using an electronic navigation chart, and then we just merge, fuse it, and then you apply an automatic navigation system where it could kind of navigate you and take you to things. So I see the time is we have left with another 10 or 15, so I will just briefly run through these slides. I don't spend so much time because I don't want to give more information on the technical side, because that will go for long. So I will touch upon very few areas. The sensors, what are the different sensors we have on an autonomous car, is that we have several companies which are producing high precise optical sense cameras, and these sensors are actually useful to enable several applications. And then it could be a one single sensor, or it can be a multi-sensor thinking. Again, a 3D sensor is very important to know the proximity, like what is near or what is next to you, and that's very critical when it comes to autonomy. You need to know what is next to you when you're in a trajectory. And here are just few examples of available sensors and which is being used, like Microsoft Nitex 2, which is has a very good not so good resolution, but it's a 3D sensor, but you also have some high-end and medium price 3D sensors. This is a laser ranging and detection and ranging sensor for proximity, which is works very well in subsea and also like underwater, and also it could work on in the night mode to know. This is developed by Sintef and an European university. Yes, so we need sensors, and then we have several 3D sensors. We have some low cost resolution sensors, which is, and also it could be more than one sensor, say multi-sensor, and in the future we will be getting more sensors at a very cheaper price. Yeah, perception, I'm just running now. So running to finish as much as possible. And perception is that once you have the data from the sensors, you need to kind of do some thinking on the data, and there deep learning helps because you're collecting data from several sensors, and then the data is a vast amount of data, which is millions of data, like a lot of pictures you need to process at a very quick time because you're driving, same time you're capturing the data, and then you need to process, and then the system needs to know what is in front of me and what is and where I am and what I'm doing. So the critical is how quick this deep learning could do an image recognition and then tell the other block that this is what you're seeing in front of you and this is what you have to do, because you have a sensory system where you capture it, you process it, and then the processed information has to be sent to a brain, the main brain, which is actually like the main controller that is driving this thing. So everything has to go in a quick way. How are we doing this? Because before you put a system onto the trial, we do a lot of simulations. So because it's very difficult to collect all these data from real time, because you need a lot of legislation permissions before you can put a test vehicle on the road to collect all this real-time data. So what we normally do, we have a very good realistic simulators, and we simulate and produce synthetic data, and these synthetic data will help you to train the deep learning model to understand, and it helps us to learn the different images where it could kind of know the environment and the objects of the real life and so on. Yes, that's where the sensor data fusion is important. Like you have to fuse the information we receive from different sensors into a meaningful sheet. Uh, there are several online portal which is free. I strongly recommend mainly the students, if you have especially in this quarantine time, you can spend some time. There are a lot of useful tools with a layman like level 0 kind of explanation, where we can learn how to do an image classification with a simple machine learning approach, and then we can go one step ahead, how to do a 2D detection. Like if you throw an image, it could kind of detect where is, like an example, like if you throw any object, it could detect where is a dog, car, a baby, and a woman. So these are something which we can learn during this period. It will be very handy, and a lot of tools are already available from Google and from Microsoft and from SkyMind. Yes, the next step is moving on the 3D. So we get the 3D data model, we get a 3D object. The difficulty is that the 3D sensors are a bit expensive, and it's challenging to get a 3D model of an wave, and then to map the 3D model into an object. And there are several lot of research which is going on to have a state-of-art 3D sensors to understand a depth of information, and it will be sure coming in to the future. But a 2D image classification, as you can see, it's so precise. It can say what is the diameter, and it can identify what color is it, and it can identify what is the direction is being placed. So you can try all this kind of image classification and recognition in the tool. One example is like Facebook, where it if you just post a picture, it just does an image analysis on it, and then it just tags accordingly, like who is this person in your contact. It can tag based on the face, and then it can tag the name of the person. And there are several front leaders who are working on this image classification. And Mobileye is a camera which is used in autonomy cars like Tesla, but Tesla has its own camera system now, and they are actually used very much in image classification. Yeah. And then I just slightly touch upon cognition point of view. Like what is cognitive thinking is, once you receive the data, you process the data, but you need to kind of relearn it again and again, like a game where you just, for the first time when you play, you don't get so much score, but when you start to play more and more and more, you know the tricks and plans of the game, then you just kind of know how to go and how to get more points. It's the same thinking, and that's called reinforcement learning in terms of machine learning or artificial intelligence. And several companies are already implementing reinforcement learning, especially for navigation systems like autonomy navigations and driving systems and so on, so that it could learn the trajectory again and again, and then it knows where it's failing, and then where it knows how to correct it. If it fails, it gets a negative point. If it does good, it gets a positive point. So we are actually building an algorithm so that it could get more positive point. And then also bringing in the cognition to it, like same in car industry, you need to know what is a human pedestrian. You need to know that if there is a pedestrian walk, then the human cannot fly because he has to walk. If there is a drone, it captures a drone, which means it can fly. It needs to know what are the, if it sees a dog or if it sees a bird. If it sees a bird, it knows the bird can fly. And then you no need to do the same kind of reaction to it. So you need to bring in some cognitive thinking into it. And then a knowledge-based system, so which means you repeatedly do the exercise and then you make the system to learn it, like how we learn to drive or swim or ride a bike. So it's like when we start, we fall down and then we try again, we learn. So it's the same thinking. So you're going for reinforcement learning. And that cognition will always give you a risk aware planning, like how to move your trajectory. Like instead of going very close to the window, you can have a very decent space between the two obstruction, and then you can navigate through properly. The same thinking is applied on the marine. You use the electronic map, and then you know where are your shallow waters, where is the land, and where you need to trajectory. So here you are kind of removing all the obstacles towards you, and then you form a better routing system. And communication, as we saw, the communication to an autonomy vessel is very critical, especially in terms of this digitalization and cyber security world, cyber security threats. So the communication is very key, that we always need to collect as many information from the vessel to do a study on that. In the meantime, we also need to take control of the vessel from the remote operation center. Yeah, and there communication plays a key role. This is my personal info to all who are listening, and there are several open source tools, and the future is more towards machine learning, artificial intelligence, and big data analysis, and so on. So it's always good that if we could kind of improve our competence in those areas, that can put you forth in a better career or in a better place. And there are several websites you can actually Google by yourself. There are several websites which has open source tools, and it's, as I said, it starts from level 0, so you can learn quite a lot of things by yourself. And to conclude, I just played just 2 more videos. I'm not sure whether I played this video before. Maybe then I just play the next video so that we can conclude the session. Yeah, this video is from Rolls-Royce, but Rolls-Royce Marine is being merged with our company. And this video is just
thank you for permission.
Artistic thinking on how an automated assisted bridge can help the operation in doing in better way. And what we can see is that a vessel is leaving Helsinki port, which is in Finland, and is going into an open sea. And you can see how all this sensor fusion and artificial intelligence and can help the operator on the bridge to have a very safe exit from the narrow port into an open sea. Yeah, with that, I just play the video for you.
To depart, we are proceeding outbound via Kusten Mika and passing Hermaya on our way out. Do you have any reported traffic in the area?
Baltic Discoverer, Helsinki VTS, one outbound vessel.
Captain, lots of small boats out today.
Not to worry, Oliver. Already seen them on the Intelligent Awareness System.
Of course you did. How are you finding the IA system?
Fantastic, Oliver. Come inside, and I'll show you. The Intelligent Awareness System has 4 user interface modes: virtual reality, 2D and 3D, augmented reality, and precision mode. We are now using precision mode, which relies on Rolls-Royce LiDAR. Precision mode provides accurate distances between vessel and surroundings, particularly useful when navigating along narrow routes, congested waterways, or whilst docking or undocking. The operator can also rotate the view like this and inspect distances in greater detail. Let's now switch to augmented reality mode. This mode gives live video feed from the intelligent awareness sensors. The object detection system identifies both static and dynamic objects, so you can see it has identified the sea markers and recognizes vessels that are not visible in AIS. By selecting a vessel, further identification information is displayed. Finally, in virtual reality 2D and 3D modes, real-world sensor data is fused with map data, and we can view our vessel in its wider environment. In 3D, our vessel and surroundings are displayed in bird's-eye view. Aside from object detection, information such as speed, heading, and distance are displayed. We can do things like modify sea marker range or define no-go zones, so that the information shown is best tailored to our needs. In addition to this, fairways and depth information is displayed. So you can see, Oliver, intelligent awareness gives me much better overall visibility.
Baltic Discoverer, this is Helsinki VTS. Have a safe journey.
Yes, with that I conclude my very short webinar. I hope it was interesting to everyone out there.
Yes, sir.
And I didn't touch more technical part of it. As I said, I just want to give you a brief introduction into the world of autonomy and where are we or what are we doing, and what is the future work towards it. And I hope it is interesting, and if might have put some thoughts onto your mind so that you can start looking into it if you're eager into it. And Kongsberg has offices in India, in Bengaluru and in Mumbai. In Bengaluru, we have a digital office where all this nice works is being done there, like all the machine learning things and works are being carried out over there. So there are potentially a lot of opportunities, and as I said, if you have free time, you can try to start learning all this machine learning thinking, and it would be very handy when you go out of the college. And I hope you had a wonderful time with me, and sorry if I had been dragging a bit here and there. And yes, and thank you all once again for spending your time in the evening on a Saturday evening, and yeah, good to see you. I hope
Yes, sir.
it will
Thank you,
be
sir.
very useful for everyone. Yeah, thank you.
Yes, sir. Thank you, sir. Thank you for a fruitful and interesting session, sir. And we have a few questions from the participant side.
Yeah.
Yes, sir. What is a surveillance range?
You mean what is the range of the sensor on board? Is that what they mean?
Yes, sir. Yes, sir.
Yeah, it's ranges from 5 to 10 nautical miles. And then you have two kind of surveillance range. It's like short range and long range. And short range is mainly to find any small static or moving objects around you. And then long range is for you to kind of prepare ahead of you. So you have two ranges around your vessel. Like you start with a 5 nautical mile circle, and then you make another 10 nautical mile circle. And that keeps moving as you move along.
Thank you, sir.
Yeah.
And we have one more question, is that how will autonomous shipping affect the marine industry?
Yeah, that's been a question everywhere, because it has put many ship operators and especially the crews they feel that they will lose their jobs if everything goes into autonomy. But the future is towards autonomy, and there are a lot of benefits when it comes to autonomy, because it will introduce a very low operating cost for the vessel. Even though if you don't achieve a full autonomy vessel, we strongly believe that the maritime industry will move towards periodically unmanned vessel, which means you actually limit the number of crews on board, but you still have task from a remote operating center, which means even though you are not physically present on the vessel, you still on a remote operation was remote control center carrying out the same operation. But it will have a major impact when it comes to the operation point of view, because it will put a lot of the crew who are already on the vessel into some kind of layoffs or thinking. But the autonomy is the idea is that it's not applied for across all the vessel sectors. That's the thinking now. It's only applied on very selected vessel sectors, and where it could be beneficial and it also be safe. So the main thing is safety. So keeping that in mind, I believe in the coming decades there will be a dramatic change, both in autonomy vehicles. We could see more autonomy vehicles on the roads. The same way we could start to see a few autonomy maritime vehicles on the sea as well.
Yes, sir. Thank you, sir. We have one more question.
Yeah.
Autonomous shipping are highly dependent on computers and robotic equipments. What would exhibit the consequences on cyber attack?
Yeah, as I said, that the cyber attack is very key thing here. So we always need to have a very secure communication, and how secure, uh, nobody knows, because we have smart minds even on the hacking industry. So whatever you come with a high level security, you have someone who can hack it. So that's the reason. That's why I said communication, especially communication towards a remote control center, is very important. So even if you have an attack, this remote control center can step in and take control of the ship. Uh, but for the moment, autonomy is planned only for short range of routings, and for the long range of travel, it's more like a decision support thinking, where your automatic bridge assistance, like the video which we saw the last, you still have crew on boards, but they will be helped by the systems on board. So we also seen I also show a small picture of a case of an autonomy car being hijacked and stopped by someone in the highway. So things could go wrong, and yeah, as the cyber security plays a very key role, especially when you have things on board and it's easy for someone to hack the ship. And as I said, it's same like a pirates. They can hack they don't need to go out in the sea. They can hack the ship, go into the controls, and then they can drive the ship wherever they want. So it's very critical, and it will be tested over the periods, but anything can go wrong. So you have to hope for the best.
Yes, sir. Yes, sir. Our last question is that what are the skill sets required for instrumentation engineer and electronic communication engineer to graduate to get into digital twin solutions?
Yeah, as I said, what we learn is the basics, which is very important. The fundamentals are important, but during this situation, I mean, it's not now we have internet facilities and remote learning facilities to everyone. It's not like in a decade before or even a few decades before. So we have a lot of open source websites where you can learn the data science. And I strongly, that's why I recommended to start learning a data science, even if you want to work in a core industry. Soon it will be data science everywhere. Every industries are moving towards digitalization. They want to kind of use data for money. So it's always nice if we could kind of improve our competence by learning, by taking some basic courses. At least we know what is the capability of a data science. There are several sectors like classification to regression and to have clustering, and yeah, there are several areas in machine learning. So that I strongly suggest that it's even I'm not an expertise in machine learning or artificial intelligence, but I'm learning day by day. So I always think that every day we learn something new. That's my thought, and I always want the participants, or especially the students, to also have the same thinking. Try to learn something new every day. The semesters and marks or something, but the key is that you have to learn something new every day, and it's always good that we look ahead and learn the latest technology, so you know things when you go out into the work.
Thank you, sir. That's the end of
Thank you.
question answer session, sir.
Yeah.
Now, I invite Dr. Rohini ma'am, Professor and Head of Lab Affairs, to express her gratitude.
Thank you, Subhash. Thanks to all on behalf of Department of ECE, St. Joseph Institute of Technologies and this group of institutions. Myself, Dr. Rohini, Professor, feel very much proud to spill the word of thanks to Dr. Krishnakumar Nagalingam, Product Advisor, Arnsberg, Norway, as he is our alumnus. Thank you, Krishna Kumar, for sharing with us about autonomous systems with examples such as cars, maritime vehicles in the context of AI and sensors. It was very informative and interesting as well. I thank our management for enabling us to keep this program. I also thank our head of the department and all other faculties for organizing this event successfully. Last but not least, I thank all the participants for their active participation in this program. Thank you all. Thank you,
Thank
Krishna
you,
Kumar.
Anal. Yeah, everyone have a nice evening, and happy Sunday. Bye bye.
Yeah, thank you.
Thank you, ma'am. Thank you, sir. I would like to thank Dr. Krishna Kumar for taking out his busy schedule and joining us today for sharing his knowledge in our webinar series. I would like to thank all the department heads, each and one of staff and student coordinators to initiating to bring together the platform to helpful for our fellow students. Last but not least, I would like to thank all the participants for the active participation. I would like to end by the quotes of Mahatma Gandhi. Keep your thoughts positive because your thoughts become your words. Keep your words positive because your words become your behavior. Keep your behavior positive, your behavior becomes your habit. Keep your habit positive, becomes your habit values. Keep your values positive because your values becomes your destiny. Thank you all. Thank you, sir.
Thank you. Bye.
Thank you, Krishna Kumar. Thank you very
Thank you.
much for
Yeah.
spending the valuable time with us. Thank you very much.
Okay.